So we'll cover one thresholding technique, which is automated. This is known as Otsu's method. The idea for Otsu's method is the first assumption it makes is that there are two classes in the image. You have water versus non-water. And I will plot the histogram. And since there are two classes, I will find the middle point of the histogram, and that will be the separation between those two classes. And you can now use statistical technique to find that threshold to do this. Let's see this article which I've linked to. This is the article on Google Earth Engine's official blog. So if you're given an image like this, you can take a single band out of it. So this is just an NIR band, near infrared band. And this image has two classes, water and non-water. You can plot histogram, is count the pixels of different types, and then find which is the separating point between those two classes. And if you do this, you will see that you'll find a threshold that separates water versus non-water automatically. One major assumption that Otsu's method makes is that you have equal number of pixels for both the classes. This example is kind of cheating because it's near an ocean, right? You can kind of adjust your viewport to say, I have equal number of land and water, and then you can find a middle ground. So if you want to use Otsu's for your data, let's say we have an urban region, how do we do this? So you can use the same concept, but make it insensitive to the proportion of land versus water. One technique that was developed and is again used widely is that you use edge detection in your image. So detect edges which are very long. So not short edges like buildings, but long edges which are water bodies. So detect long edges in your image and then buffer that edges outside and inside. And that ensures that you have some pixels inside water because there'll be edge of water. And it'll be outside, it'll be not water, inside will be water, and then you can do Otsu's. This is a paper you can read. They developed a global water mask using this technique, Otsu's thresholding plus the Kenny edge detection. And the code that was developed as part of this is available as open source. So we'll see how to use this with your own data set. In your supplement, under the surface water folder, we have the Otsu dynamic thresholding folder here. So here is our image, the same image we used in our first module. We have computed M NDWI. So this is our M NDWI, and we want to figure out what's the right threshold. This is the original histogram. If you just plot the image histogram, this looks like this. This is the values of the pixels and the count. And you can see there's no clear separation, right? It's just because there's so much of land. It's an urban area. There's more land than water. So again, water is somewhere here. You can see there's water greater than 0. You can't even see on the histogram because there's so fewer pixels. So what you do is you do the edge detection, you do the edges. So when you run the edge detection, this is what you get. So if I zoom in and you're just running an edge detection kernel over this, and you'll see that the edges will appear as is red. So these are all the sharp edges where there's a high change in pixel values. And you can see these are all, once it loads, you can see these are all water bodies only. Because in NDWI image, where there's a sharp change, well, when there's a water body. Right? So you're running this edge detection on the NDWI image, and you get all the water bodies, and then you buffer them inside and out. And once you do this, you'll see that the histogram looks like this. So this is a histogram around the water bodies, inside and out. And now do you see the separation between two peaks? Well, looks like this is all negative, right? So this is all not water, this is all water. And now you find the middle ground. And the middle ground will be the threshold, which will be the ideal threshold for your image to detect water. And again, the code uses this function, compute threshold using Otsu. This is again from the paper that was published. We can just call that function. So we call this function here, compute threshold using Otsu. It takes some parameters on MNWI, and it just prints the threshold 0.005. and you say water is m into wi greater than the threshold. And then that's your automated water detected from Otsu thresholding.